All right, we're going to do a little bit of piecewise functions. Piecewise functions should be a review, but let's just look at what we're doing. So if I have something that tells me f of x equals, and then I'm going to have different rules. So if I have something like this and it tells me to analyze f of 2, what that means is I'm going to figure out where does 2 land, which one of these x's has the value of 2, and that would be right here. 2 is in between -3 and 10. So that means my y on this function follows this rule. So I'm going to plug in 2. 2 squared is 4. 2 times 9 is 18. 4 minus 18 is -14. So they're fairly simple. Sometimes they'll give me a value that's not possible. F of -5. -5 is not less than -7, and -5 is not greater than -3. So there is no -5. The function essentially cannot have an x of -5. So I would put no solution there. I like to do my no solutions as empty sets, which means it's the Batmans with nothing inside of it. That's the main part of what we're going to be doing is evaluating at certain locations. So what you need to do is you need to be able to read this portion to see where your x lands and then plug it into this portion over here. And hopefully that is fairly old information that you already know how to do. We'll also try to write the function rules off of a graph. Writing piecewise functions is pretty hard if your graph is ugly like the one I'm about to draw, but hopefully we can get stuff that's a little bit better on the assignment. Hopefully I can do that. So since this is pre-AP pre-cal, I'm going to make things a little bit tougher on you guys by giving you multiple kinds of things. This is quadratic, obviously. This is linear, obviously. And this is absolute value, obviously. So you should be able to know the vertex form of quadratic and an absolute value. So that means my function rule is going to equal. I'm going to do the ifs first because that's I have three different parts. Excuse me. So I'm going to do the ifs first. The ifs are where do my x's happen. This quadratic happens from there to there on the x's, which is -4 to -1. So if -4 is less than or equal to, because it's filled in, x is less than, because it's open, -1. This piece right here goes from -1 to 3. -1 is less than or equal to x because it's filled in, is less than or equal to 3 because it's on the line. And then the absolute value is going to go from 3 to infinity. So if x is greater than or equal to 3. Now I'm going to write the rules. So to do my quadratic, the first thing that I'm going to look at is the vertex, which is right here. I'm going to say that's at -2, 1. So it's going to be x minus 2 squared plus 1. That's in vertex form. Then I need to see how quickly it rises. I'm going to use another point to make it easy on myself. It goes over 1 and up 2. The standard quadratic change is over 1, up 1. So this is twice as big of a change because it's going up 2 instead of up 1. So I'm going to multiply this whole function by 2. And that will give me every single value. This line is just at y equals 1, 2, 3, 4, 5. So it's just 5 anywhere in between here. This the vertex is going to be right here, which I'm going to say is at 4, 1. So absolute value of x. Ooh, this should have been plus 2. Thanks. Good job, Lothamer. X minus 4, and then plus 1. And then the standard rate of change on an absolute value is over 1 up 1 all the way. The next point that's going to be the easiest to use is this guy right here, which is at 3, 5. This point right here was at 4, 1. So that means that I went up 4 and to the left 1, which is negative 4, or negative 4 over 1. So, if I have a negative slope here, I have a positive slope here. What I really need to look at to see if that's negative, which I don't know why I just wrote it down. What I need to look at is it facing up or down? It's facing up, which means my A value is positive. So this actually should be positive 4. I don't know why I just wrote it down like that. That was dumb. So this is how we're going to write it out. Hopefully that's mostly just a jogging of your memory. What I really want to focus on is getting the equations of these little parts, getting the function rules of the little parts, and then we're going to spend quite a bit of time evaluating at certain spots. So hopefully that makes sense. If you have questions, bring them with you to class.